Hello and welcome to a little bit about adding and subtracting rational expressions. We are going to be covering three things and just one example of each. How to add and subtract when there's already a common denominator, how to add and subtract when they're almost a common denominator, and what to do when they're nowhere near having a common denominator. So we'll go ahead and start with the first one. When you have something and you are adding or subtracting, and it's very important that this is only for adding and subtracting. If it was multiplying and dividing, you don't need a common denominator, but with adding and subtracting, you do need a common denominator. So I'm going to write myself a little note there, common denominator. We will need a common denominator. So for the first one, as I mentioned, it already has a common denominator, x minus 5 and x minus 5. If they are the same, then your answer is going to have that same denominator, and the tops you're just going to kind of do together. So 2x minus 5. Now those two things are not like terms, so you would just have to write 2x minus 5. Now sometimes you can simplify more, sometimes you can't. You can only simplify if you see the exact same thing on top and bottom. This one says 2x minus 5, and this is just a regular x minus 5, so there's nothing to cancel here. So that's just going to be the answer. If this was like in parentheses or something, then those would be the same and you could cross them out. But as you can see, they're not. So, in number 2 here, they are almost a common denominator. This one says AB, and this one says just A. So the only thing that's really missing is that little b right there. So what you do is you put the b there. So they both have an a and they both have a b. The thing is, in math, you can't just randomly put a b wherever you want. When it comes to fractions, you can put something on bottom if you also put it on top. So we are going to multiply the top and bottom by b. So you would have 7 over AB plus 2b over AB. And once again, now that they have the same denominator, you can just write AB on the bottom, and this is 7 plus 2b. Once again, those are not like terms, so you can't actually put them together, and there's nothing to cancel. So that's the second example. Finally, for the last one, which is a doozy of a problem. As you can see, these are nothing alike. What you're actually going to have to do in this problem is factor the bottoms. With adding and subtracting, there's usually no point to factoring the tops. I mean, in this one, you can't factor them anyway. But you always want to factor the bottoms. So I'll write myself a little note. Factor bottoms. Did you know writing notes is good? So we are going to factor the bottoms. Here, you do the old school, what multiplies to negative 3 and adds up to 2. Now, the only thing that multiplies to 3 is 1 and 3, so I know this is going to be a 1 and 3. It's just how do you take 1 and 3 and make positive 2? And that's going to be, I guess, a positive 3 and a negative 1. So x minus 1 and x plus 3. Whereas over here, this one is a difference of squares. It's the one where you can take the square root of both parts, and you would get 3. So the square root of 9 is 3. So you put 3 in both places, one's a plus, one's a minus. That's difference of squares. Or if you prefer, what multiplies to negative 9, and that's 3 and negative 3. So you get those two numbers. As you can see, these both already have an x plus 3 in common. That is good. Kind of like in example 2, where they both had an a, these both have x plus 3. However, this one over here does not have an x minus 1. So I'm going to put an x minus 1 on top and bottom. So now they both have an x minus 1. And they already had the x plus 3. So this has an x minus 3, but this does not. So I'll put an x minus 3 on top and bottom. So then they both have an x minus 3. And as you can see, they have the exact same bottoms. So they have a, common denominator. And that common denominator is this whole thing. X minus 1, x plus 3, x minus 3. Here, you would distribute. So 2x minus 6. Bring down that plus sign. And then distribute this x. X times x is x squared. X times negative 1 is negative x. Okay. If I did that fast, you can pause it and re-look at it, or you can rewind and re-look at it. But put the tops, and then we distributed, brought it down, and make sure you carry down that plus sign. If you combine like terms and put the x squared first, then we got 2x minus x is just a regular x. And then there's this minus 6 right there. All of this over that same thing. And sometimes this is just your answer. There's nothing you can do. But in this case, it's not your answer because there is something you can do. That's that it turns out that this top one is actually factorable. There are numbers that multiply to 6 and adds up to 1. So, if you want, go ahead and pause it, see if you can figure out what it factors into, just so you're not mindlessly watching this video. So what factors x squared plus x minus 6? So this will both be x. Multiplying to 6, you could do 1 and 6 or 2 and 3. Which of those will somehow get you the 1? Multiplies to 6, adds up to 1. That'll be 2 and 3, and it looks like it'll be a positive 3 and a negative 2. So negative 2, positive 3. And look, turns out you have something on top and bottom that's the same. So choo-choo, those can cross out, and you just have an x minus 2 on top, and on bottom you have an x minus 1 and an x minus 3. And now there's nothing else that's the same on top and bottom. Notice that I didn't put this in parentheses. If you want, you can put in parentheses. I don't really care. It won't matter. But anyways, that's the full answer. And that is the 3 types of things you can do with adding and subtracting. When there's already a common denominator, when you just have to add something to one of them because they're almost the same, and what if they're completely different. So hopefully that helped. If not, then you'll get help elsewhere with Edmentum. And that's it. Bye.